Today's session is going to be real-time RAG and agentic analytics. But we're going to start off with kind of understanding what vector database is. So who's here used a vector database? Who has put a RAG application together? Okay, well, I can just leave. But no, I'm kidding. So I'm Hubert. I've written a couple of books. More on that later. But I'm going to skim through a lot of this stuff so they can get the basics, and then we'll cover the interesting stuff in a second. So what is a vector? Basically, a vector is, I can create a vector out of these two sentences here. I love data, I love candy, and I can create these two vectors here where I just tally each word in those sentences and as a number in the column. This is called a bag of words. So that's a vector, basically, right? It's an array of numbers. What is an embedding? Well, an embedding is something that creates vectors, or basically embeddings, that from a neural network that's more sophisticated. For example, if I were to put the terms good and not good, a bag of words would actually relate those two pretty close together because I'm tallying those two words together. But if I were doing it in an embedding model, it would actually create those two sentences as being very different because they're negatives. Okay. So what's a vector index? Well, we all know what an index is. It's a way to retrieve data from a database really quickly. Well, a vector data index is a index that allows you to retrieve vectors really, really fast with low latency. Okay. I'm sorry? Oh, bigger. Yes. How's that? More? Yeah. You want to scoot up in a couple of rows? Maybe you're in the back. That's cool. You know, I'll make it a little bigger. There. All right. Okay. A vector database is kind of encapsulates all that idea into a single data store. So if you want to get started with a vector database, you can install something like a vector index or a PG vector in the Postgres. Just go to the GitHub repository, do a simple search, clone it, install it. There's really simple instructions, and then you're good to go. So what I'm going to do is actually do all of this live. This, as you notice, is a Jupyter notebook. I have Postgres installed locally. I've already installed PG Vector. It's a really simple batch process or make file that you just run and it automatically installs it. So nothing too sophisticated there. But what I'm going to do is actually install it into Postgres and start using it as a vector index inside Postgres. You can see that I'm using the connection, this local connection. And I'm using this model called a clip model, which is a multimodal model. This is what I'm going to use to create embeddings from my unstructured data, okay? My unstructured data initially is going to be images. So what's multimodal? Basically, it's a model that allows you to create embeddings out of multiple modes. For instance, take images or videos or text, create embeddings out of them and put them in the same vector space. So I can say, give me cars, which is text. I can create that into an embedding, and images will return, the vector index will return cars, of pictures of cars, which is also a vector inside the database. But they're all, one's text, one's an image, but they're closely related to one another, so the vector index will return those two. So that's what a multimodal model is. It's able to do that for multiple types of unstructured data. So we're going to set up the database. Notice this is how you set up the vector. You just create an extension if it doesn't exist. And then I'm dropping some tables that has my images already, and I'm recreating very simple stuff. I'm going to this directory here and loading all my images. Okay, once that's done, I can go into here and show you the contents. So This is just an integer. This is the path to my image. And this is the vector, or this is the embedding for that image, okay? So we're not actually converting the image into a vector. This has only semantic meaning of the image. I can't reverse this embedding and create the image. It's only semantic meanings in numerical vector form. If I want the image again, I have to save the path to it and retrieve it later, okay? Okay, so we have that there. So what we're going to do is just ask it for some pictures. In this case, I'm going to ask for some Van Gogh paintings because I know that I have some of those in there. So let's do that. And there they are down there. So quickly, what this is doing. This is the embedding field. Right, this is where the embedding is. This is the table. And this is right here a distance algorithm. And this happens to be telling the vector index to say, hey, take the image embedding and my question, which is this, my query string. I'm using the same model that I use to create embeddings out of my images. And I'm using that to create an embedding out of my string. And I'm putting that in my query statement to see how far these two embeddings are and get similar images back, okay? That's what this is doing. I'm saying, give me 3 of those, and I'm showing them. When I print out the results, I'm printing out the number, the ID. I'm telling you the path to it, and I'm actually also telling you how far the distance is between the text embedding and the actual image embedding. That's how far that is. If I were to go in here and say something else like give me, oops, you'll see that that distance will get bigger, 11. Why? Because this is not we're not using an LLM here yet. We're not asking questions. We're only taking the text here and creating an embedding out of it and seeing it's how close that text is to that image. Give me convolutes that text. I only want Van Gogh paintings here, and that can confuse the vector search. We're only doing similarity search here. We're not using a chat GPT or LLM here in this case, not yet. All right, so what are distance algorithms? These are the things that allow us to find the similar images in the database, right? There are, in PG vector, there are 4 different types of distance algorithms. They are basically ways to triangulate between 2 points. So Euclidean is just finding the hypotenuse of a triangle. You've done that in your simple geometry class in school. Manhattan assumes that there are obstacles in the way between A and B. So if you think of yourself being in a Manhattan, a point between A and B typically has buildings in the way, hence the distance algorithm Manhattan. Cosine distance is basically kind of this angle down here. How wide is that angle between A and B? L1 is very similar to, or I'm sorry, inner product is very similar to Euclidean, but I'm not going to go into that. So that's basically similarity search in a vector database, okay? But what does real-time RAG mean? This is this is current. There's got to be streaming somewhere, right? So typically, when you build a RAG system, is a lot of people do it batch-oriented. They get a bunch of documents, like your documents to your application or an article. You chunk it, you break it into pieces, and then you send each piece through an embedding model. And usually the normal path is you batch that into a vector database. But if you want that in real time, you would stream it. You send those embeddings into Kafka and then do an upsert into the vector database. So this is basically the top line up there, obviously, is the real-time integration into your vector database, which enables you to do real-time retrieval, because the assumption is that this same vector database here is being updated using streams, and now you can get fresh queries, results from a query. So if I were to go build my RAG application and I ask a query, that query gets converted into an embedding model, or it goes through the embedding model and it gets converted into an embedding, and then sent to a vector database, and the content of the original text, in this case, because it's documents, gets pulled out of either the vector database or externally and joined together with the query to create a prompt. This prompt is then sent to the LLM, and the LLM responds to it. If this context was empty, usually what the LLM will say is that I don't know anything about this question that you sent me. I don't have the context. This is going to keep your LLM from hallucinating. Otherwise, if you go straight to ChatGPT and ask it the question, hey, when is my session start today in current, it's not going to know, because it got trained a couple months ago. It doesn't have the information of today. Using this method, by consuming documents, every time they change, you send it and stream it into Kafka and into your vector store. You could build a real-time RAG and get fresh results from your questions in your RAG system using with your LLM. So Apache Pinot also has a vector index, right? So we're talking about two different databases here. So far we did Postgres, which is an OLTP database, Apache Pinot, which is a real-time OLAP analytical system, right? So when do you need each, right? So quickly on how Apache Pinot's vector index is implemented, it uses HNSW, which is one of the faster vector indexes. This is how it's implemented. I am not going to talk about this. It's complicated. I'm not even sure that I understand it if I were to regurgitate that to you. But basically, from what I understand, it goes through some levels and drops down depending on how you're providing the parameters. But each one of these groups here is going to provide you with a faster lookup to those similar vectors. But the real question is that, because we're talking about Pinot now, and I started off with Postgres. Started off with Postgres, was really easy to get started, and that's what everybody knows and loves and tries to use initially, and it's great to get started, right? You saw me just use it with image search. Like if you can go to Google and your Google Photos, you can type a search thing at the top there and it'll get all those similar pictures. You can build that really, really easily using this vector index. But when should you use an OLAP? Well, think about how many people are going to do this query against your database. How many milliseconds do you need to be able to respond? Concurrency is important and latency is important. If that threshold exceeds what your database can handle, you may want to think about doing something with more analytical power. Right? If you're going to add analytics, count me the number of items that are similar to this, that's an aggregation. That is a similarity search plus an aggregation. That requires an OLAP database, right? You may want to consider using an OLAP database for your RAG retrieval. I'll give you another an example here. In New York City, there are about 50,000 cameras, street cameras in New York City, all 5 boroughs, right? And according to Llama 3, but I trust it. If each camera captures a frame every 10 seconds, you'll get 157 billion frames for the year, right? That's every 10 seconds, right? That's what that looks like. If you were trying to search for somebody or looking for something specific in all those frames, you probably don't want to go more than 10 seconds. At 20 seconds, you could miss maybe quite a lot, even an accident or something. But the idea here is that if I want to search through all of these images, I need something really powerful because I'm probably going to ask subsequent questions based on what I've searched and found in this in my vectors. So moving away from images, I'm going back to a different use case. And this use case, I'm going to use StarTree Cloud, which is Apache Pinot in the cloud. And in here, I have some tables. These tables resemble a clickstream or funnel analysis type of dashboard. So let's take a look at what's inside of some of these. The clickstream, let's see if this works. So there's a click. The others are pretty boring except for this product. So if I look at product, preview this table, product has embeddings in it. It's because I want to be able to do recommendation. I want to be able to recommend a product to something that somebody's bought previously, or maybe in that type of user or customer that's using my application. So I have a clickstream analysis going on. And typically, when you look at clickstream, you see a funnel. So I'm going to run this. This is going to build me a funnel. Okay, all I'm doing is looking at the event type and then just counting them. And this is what that funnel looks like. You know, I get a click, then I get a view, then maybe a save. There's probably more to this funnel, and then a purchase, right? And if I were to look at this diagram, it's very rigid. I can't go beyond the bounds. I may be able to drill down or aggregate up again. I might be able to even navigate to a separate chart that tells me even more, but it's very rigid. I can't do much with it. And to overcome that, I want to use something called agents. And I believe in my heart that this is the next generation approach to getting real-time analytics. The idea here is that we still have a query, but this query is going to go to an agent. And this agent is assigned tasks. You give it a task. You tell it what it is. Your role is blah, 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 right? And in order to accomplish this task, you give it a set of tools, right? And this will help in combination with the LLM, give you a good response to what you're trying to do. This is kind of like high level, but let's see what I'm talking about. I'm going to build an agent right in front of your eyes. But basically, all this is doing is, so I'm getting a connection to Pinot in the cloud. This is my embedding model that I'm going to use is OpenAI. So that's what I'm going to use for my similarity search for my products. And here are the tools I'm going to build. Get all the users. Get a user's detail, so you need to pass it a user. Get recent purchases for that user, so it's another parameter. Get similar products, given the product description, so this is going to create an embedding. Do a similarity search. This is Pinot's vector index. Notice it's in the where statement, and it's going to do a distance HNSW vector index search on this. But notice up here, I'm going to analyze the output of these distance algorithms. This is a cosine distance. This is the Euclidean, I think, and this is Manhattan distance down here. I want to look at these distances and maybe estimate which distance algorithm makes the most sense, right? And I'm going to order by the cosine because I configured this table to have a cosine vector index. So let's take a look at that again. So yeah, this properties here is using HNSW vector index type with cosine distance. So this is what I'm relying on, but I also want to know what the other distance algorithms are returning. Then this is going to iterate through them and then return a product that is, the top 3 products they might similar to that description. top 3. This is just the top 3 users that have purchased recently. And the most time spent. Who are the users that have spent the most time on the application? So those are the tools that I've created. And here I'm creating the same tools, but I'm providing some metadata. So these are the metadata that gets consumed by the LLM to help it decide whether even to use these tools or not. So far, I'm not doing anything hard here. I'm using the same tables that I used to build my rigid dashboards and using now AI agents to consume those same dashboards, but have a more interactive approach to analytics. So now let's create the agents. I'm going to give it the set of tools that I just created on top. Here is my LLM that I'm going to use. I'm going to tell it, hey, show me a debug view of what you're doing. And this is the task. This is the task that I've assigned the agent. So basically the agent is required to find users to, find ones that we could incentivize and maybe do more, customer retainment, and et cetera, right? So let me make sure I run this. So I've created my agent. So that's it. Now we can ask it some questions. I just have a while loop, but typically you would want a chat interface and maybe alongside what you already have in your funnel analysis, create a chat box there, and then ask your analytics some questions. So I'm going to ask it, who is the top user? So as first is calling this tool here, who spent the most time. It got 3 users. Now it's calling get user details. It got only 1. It got the first person. And the ID is that this is his address. So would you like to reach out to him with incentives? Sure. So it's going out and getting his getting his recent purchases. It's going out and using that description from his recent purchase and finding similar, doing a vector search on the products table, doing a similarity search, and then returning that product back to the LLM. And now these are the results. The product is some headphones, high quality headphones. And here's a message to Brian. Hey, thanks for being whatever it says there. So now you've basically taken a really inflexible dashboard, added some AI agents on top of it, and now you're asking more real-time, robust, really rich questions that you could never really ask. You actually had to go to a developer and get this information yourself. Or maybe if you knew SQL, you'd have to go to the database and look up these questions and answer them yourself. Now you've actually expanded your whole real-time view of your business through agents and the just utilizing the same tables that you're using in your existing dashboards, right? Good. So what can you do with this? I only have one agent. You can have multi-agent systems. You could add another agent that says, I want you to create me a dashboard. So it'll make you a dashboard that, if it's not specific enough, give me what I need to be able to render, a widget in this UI and create me a new dashboard with these filters or these parameters. You don't have to have the LLM build you SQL. You could just strictly define the tools that you want it to do. If you know the task, you should be able to determine what the tools are required to be able to accomplish that task, and then off you go. There are a couple of steps here you need to kind of figure out. Just so sometimes if you ask a question, for instance, give me the top 10 users' addresses, for instance. It will go and get the top 10 users and then have to call for each user that one function for to get the address, because I only have one function that says give me this person's contact information and then one user. I could change that to be like an array of people and then have that one call return more addresses instead of just the one. So you want to optimize some of these calls. You don't want to keep going back and forth. That probably won't scale, and if it'll affect the number of concurrent users that are using this application. So obviously you need to monitor, set it to the verbose. By the way, I'm using Llama Index. You could use, where is that? I'm using Llama Index. You could do the same with many other agent or AI frameworks out there, like what do you call them? LangChain. There's Crew as well. I just happen to know Llama Index pretty well. It's really easy to use. But yeah, you can contact me via this QR code and track me down the hallways. All right, peace out.